right, here we start partway into example 2. We have an equation we're going to graph. R equals 4 minus 2 sine theta. We're going to plug in values between 0 and 2 pi, or since I chose to use degrees here, I'm using values between 0 and 360, so I can just use those memorized numbers that we already know. So I plugged in a 0, and I got 4 minus 2 times the sine of 0, which is 4 minus 0, which is 4. And then the next one I'm doing 30 degrees, so 4 minus 2 times the sine of 30, which is 1/2, so 4 minus 1 is 3. And then for 60 degrees, I'm going to have 4 minus 2 times the square root of 3 over 2, so it'll be 4 minus the square root of 3. So yes, we'll have a decimal. What's 4 minus the square root of 3? I have approximately 2.3. Okay, so I'm just going to do an approximate 2.3. All right, let's go to 90. So R equals 4 minus 2 times the sine of 90, which is 1. So 4 minus 2 is 2. And then 120. The cool thing about 120 is that that gives us the same answer as 60, doesn't it? So we don't need to recalculate that one. And then 180. Oh, I went to 150, right? So 150 would take us to back to 3, the same as 30, because all students take calculus. Sine is positive in the second quadrant. And then 180 takes us back to 4. Okay, now are things going to stay the same or different when we go past 180? So let's see what happens here. If I do 210, let's figure that out. So R equals 4 minus 2 times the sine of 210, which is 30 degrees. But it's a negative in the third quadrant. So that's going to give us a negative 1/2, which turns that into a positive 1. So we're actually doing 4 plus, isn't it 5? Okay. Obviously, I didn't give us enough space to go all the way to 360. So maybe we just need to kind of recognize the patterns that are happening here. You can throw more numbers in if you want. I'm going to go ahead and jump to 270. So I know that's quite a jump, but it's okay. 270, so R equals 4 minus 2 times the sine of 270, which is a negative 1. So that adds up to 6. Then if we go beyond that, maybe clear over to 330, that's another 30-degree reference angle that's negative. So isn't that going to be the same as 210? So that's going to take us back to 5. And if we go clear to 360, what's that going to do? Restart it, so it'll be back to 4. Okay, so let's go ahead and plot these points and see if we can figure out what this looks like. So we'll have a point at angle 0, radius 4, 1, 2, 3, 4. Angle 30, radius 3. Angle 60, radius 2.3. Angle 90, radius 2. Angle 120, radius 2.3. I think you called this a peach shape when you were looking at Desmos the other day, weren't you, Adrian? So 150 was a 3, and 180 is 4, and 210 is 5, and 270 is 1, 2, 3, 4, 5, 6, and then 330 is back to 5 again. Okay, so we end up getting a shape that looks, if you want to call it a peach, you can. We call this a cardioid. I'm pretty sure. Let me look at my reference sheet. So, oh, actually, that would be a limacon. What's the difference between a cardioid and a limacon? I don't know where that word comes from. Yeah, I didn't draw it very smoothly, but. So you can see that this should kind of follows this pattern right here. r equals a minus b sine theta. Let's look back at that formula we just did. So we have a number minus a number times the sine of theta. And this number is bigger than that number. So that fits the pattern on our reference sheet, number minus a number times the sine of theta. I know you're all thinking, can we use this reference sheet on the final? No, you cannot. But this is just to help you understand these as you're doing them. You don't need to memorize these. Yes, there will likely be one of these on the final exam. I've seen them put one of these, and they usually give you a table of values, just like I've done, and you plug in some points and you sketch what it looks like, and you will have had enough experience with it that you'll be able to handle it. You'll be able to do it. I don't think they will care what the name is or not. So I wouldn't worry too much about that. In fact, I don't even know what your final is going to look like this year because it's all going to be multiple choice. So, okay. Any questions on that one, that limacon? Let's look at the next one. If you want to, you can now go and look. This number is smaller than that one. This is a plus, and that's a cosine. Let's look at our reference. What is this one going to be? If Right, so wait, it has the plus in it and it has a cosine. So it's going sideways, and that's interesting. So it's still a limacon, it's just going the other direction, sideways instead of up and down. So the cardioids happen when those two numbers are exactly the same. So you have a number plus or minus the exact same number times the cosine or sine. That gives you the cardioid. And then, so a cardioid is actually going to intersect at 0, 0. The limacon is a little bit off. So in that case, the one we just did has a point at 2, right? Does that make sense? Lauren raised his hand. It's okay. Yeah, cool. Okay, the next one is with a loop. Here, what makes the loops happen? Oh. Oh. Maybe he doesn't want to interrupt or he doesn't like to unmute himself. Look at that. You're right. These A is greater than B and that gives us a limacon, but when B is bigger than A, like we're going to see on the next problem, we're going to get a limacon with a loop. Awesome. Okay, let's do it. All right, let's do this. So we're going to plug in 0. So r equals 2 plus 4 cosine. I probably should have stopped my video after the one problem, huh?